Here is a brief introduction to Sniftek. First, I'd like you to take a deep breath. Hold that breath, count to 3. Now slowly breathe out. The breath that you have just breathed out can reveal a lot about your health status. It can identify whether you have any cancer, such as lung cancer, liver cancer, breast cancer. It can identify if you have any infectious diseases, such as COVID or pneumonia. It can identify if you have any chronic conditions. Think of diabetes. Think of COPD. And it can also identify whether you've been following a particular diet. So that information is extremely useful. Let's talk about the trade-offs that there are in healthcare as we try to make health assessments. And typically that trade-off can be divided between those ways of ascertaining health status that are fast, low cost, and non-invasive, and those technologies that are detailed, accurate, and reliable. When we think of fast, low cost, and non-invasive, think of temperature, blood pressure, physical exams, height, weight, things of this nature. And when you think about those assessments that are detailed, accurate, and reliable, think of blood chemistry, imaging, taking a biopsy and analyzing it. The promise that breath analysis can provide is that it can be a combination of both of these. It can be fast, low cost, and non-invasive, and it can also be detailed, accurate, and reliable. So that's the opportunity that exists for using breath biomarkers for health research. The challenge is that there's over 1,000 different breath biomarkers. Many of those are volatile organic compounds. So there in general has been hundreds of studies that are done each year, and 2 general approaches for generating breath prints and then understanding the health that sits behind them. One of those approaches involves taking a sample of the breath, as you're seeing this person doing here, breathing into that Tedler bag, and then analyzing it on a sophisticated machine such as the analysis that I'm showing you here, which uses gas chromatography and mass spectrometry. Those machines are very expensive, which means that the work needs to be done offline. So by using this for breath analysis, we have an approach that's non-invasive, it's detailed, it's accurate, and it's reliable, but it's high cost and it's slow. You don't get the results the same time that you've taken the test. The alternate approach is something that relies on sensors. So we're talking about electrochemical devices that can read the different gases in these breath biomarkers. Here is an example of the generalized approach. So patients will breathe into a device. An array of sensors will register that breath. There is signal processing involved, and then there is data analysis on that signal processing in order to identify the particular conditions. The problems with this approach are that it is also non-invasive. In this case, it is low cost and it is fast because it can be done at the point of care. But there have been issues with accuracy and repeatability. So this is where Sniftek steps in. Our objective is to combine the best of both of these approaches for measuring breath biomarkers. The way we are doing that is we use a more sophisticated sensor array, and we are also investigating technologies such as thermal desorption to separate the mixed signals. When we combine that information, we end up with an approach that is for health assessment that is non-invasive, low cost, fast, detailed, accurate, and reliable.